Hi, welcome back to another episode of Algebra in Words. We're going to continue our discussion in this video about linear equations. Particularly, we're going to start off with how to plot a linear equation on a graph. So on the board, I have an equation, y is equal to x plus 4. And just to point out, this equation currently is in slope-intercept form, y equals mx plus b. If you're wondering what m is, in this case, the slope, it's 1, which is an unwritten coefficient of 1, so it's just x. And the 4 is the y-intercept. But the first method we're going to look at to graph is using a table of 3 points. Okay? So just generally speaking, let's talk about why you should have 3 points always to make a line on a graph. If I sketch a graph, you need at least 2 points to make a line. Let's just say it's those 2 points there. Okay? You can connect those points. You need a minimum of 2 points. Okay, I think that's easy. However, what happens if you do the method that we're about to look at, but you get this, a triangle of 3 points? Well, that makes the point that we use 3 points kind of like as a check mechanism. If all the 3 points fall in line, there's a pretty good chance that those points are correct, and you'll get the correct line. However, if you only have 2 points, what if it was these 2 points? You'd get this line. Or if it was these 2 points, you'd get this line. Or these 2 points, you could get that line. So if one of the 2 points is wrong, you'll get the wrong line. But if you have 3 points, and they're all in line, then that tells you there's a pretty good idea that you have an accurate line and an accurate graph. So that's what we're going to do. Now, most books do tell you that in this method, which is making a table of points, most books will tell you to just make up 3 points, start off with make up 3 random x values, plug the x values into the equation, solve for y, and get 3, and you'll ultimately get 3 points. I'm going to give you a method that is basically the same, but I think is a little bit easier. It's the method that I do with my class. So let me show you what that is. I call this, it's just a made-up name, I call it the 001 method. Okay, and here's why. I made up a basic table with x in the left column and y in the right column. And I made 3 slots. One for point 1, one for point 2, and one for point 3. In the x value for the first point, I put 0 for x. In the second line for the second point, I put 0 in for y. And in the third point, I put in 1 for x. Alright, I'm going to explain why I use this method and choose this method and recommend this method. Basically because 1, it's easy to remember, and 2, it's easy to apply. And when you think of 001, it's something that you could do very repetitiously, so when you have to graph a line, it's not that much to think about, and there's consistency in this method. Okay? Also, as I sort of said, when you're dealing with numbers with 0 or 1, plugging into the equation, it's gonna allow you to simplify the equations pretty quickly. So let's get started. Let's start with plugging in 0 in for x into the original equation. So I'm going to write y is equal to 0 plus 4. If you simplify, we get y equals 4. I got y equals 4. I'm going to put that 4 into the table. That's our first point, 0, 4. Alright? Now I'm going to put in 0 for y. 0 is equal to x plus 4. We want to isolate x. This is already in positive x, so let's subtract 4 from both sides so that we get negative 4 equals x. You could flip it if you want to say x equals negative 4, But basically, now we're going to put this negative 4 in for this point that corresponds with the point when y is 0. And now we're going to do substituting 1 in for x. So rewrite y, put 1 in for x, rewrite the plus 4. 1 plus 4 is 5. So y equals 5. And now we got 3 points. And it was easy. We used the 0, 0, 1 method by using a table of 3 points. Okay? What you also may want to do, just so that it looks more like a point, you could put those points in parentheses. We're used to points in parentheses. It just looks more like a point or an ordered pair. So I'm going to erase the math, and now let's graph these. I'm going to sketch just a basic graph. Remember that as you move to the right, x is positive and goes up. If you move to the left, it goes down. As you go up, y increases, and as you go down, y decreases. So we're going to start at the origin, and we're going to plot 0, 4. So starting here, x is 0, so we don't need to move horizontally, but y is 4, so we're going to go up 1, 2, 3, 4. Draw the dot. I'm going to even label it, and that part's done. Let's do the next point. We have negative 4. 0. So we're going to start at the origin and we're going to go to the left. 1, 2, 3, 4. Okay, y is 0, so we don't have to go up or down because it's 0. So we'll draw the point and label it. And then we'll do the last point. 1, 5. Starting at the origin, go to the right 1, and we're going to go up 1, 2, 3, 4, 5. Sorry that they kind of overlap. I'll just draw an arrow. This is 1, 5. Okay? Before we connect the dots and draw the line, just give it a glance. Okay, I realize it's a rough sketch, but the dots seem to fall in line. It does look like they fall in line. So draw the line through the points as best you can. And we're done. Okay? One little quick comment that I want to point out about the graph. What is the trend of this line? Is it positive or negative? And how do you answer that? Well, you answer that by asking this question. What does the line do? Does it go up or down as you move to the right? And the answer is, it goes up as you move to the right. Therefore, we would say that this has a positive slope or a positive trend of the line. Okay? If we wanted to look at that from another perspective, we could look back at the original equation, which must be in slope-intercept form, which this is. What's the sign of the slope? It's positive. So that agrees with the positive trend of the slope of the line or the positive trend of the graph. Okay, I'm going to erase this. Let's look at another one. Okay, so I erased the last work and I put up a new problem. I chose this equation for a certain purpose. 3x minus 2y is equal to 0. Why did I choose this equation? It's a little different than the last one because the last one was in slope-intercept form, but this one is in standard form. ax plus or minus by is equal to c. In this case, c is 0. Okay, so I chose this because it's in a different form as the last one that we did. But the method is the exact same. Notice I have my table. We have x is 0, we have y is 0, we have x is 1, and we're just going to plug in for each of those. Starting with when x is 0, 3 times 0 minus 2y equals 0. This becomes 0 because 3 times 0 is 0, leaving us with negative 2y is equal to 0. Let's divide both sides by coefficient negative 2. These cancel out to 1, leaving y. 0 divided by negative 2 is 0. So when x is 0, y is 0. I'm going to plot that. Now, we could go through the motion again and put 0 in for this and figure out what that's going to be. But if you look at the line above it, we already know what that's going to be. It's going to be 0. So this will, in essence, I'm going to write 0 there, but this in essence will be a duplicate. That's another reason why I chose this, because I want to look at what to do when we do have a duplicate. Okay, so let's plug in 1 for x and find out what that is. So 3 times 1 minus 2y equals 0. This becomes 3. This stays negative 2y equals 0. And let's add 2y to both sides to move the term with the variable to the right. So we get 3 is equal to 2y. Now divide both sides by coefficient 2. And the 2's cancel out. Y is equal to 3 halves. I'm going to put 3 halves here if you want to convert that to a decimal. It's 1.5. Okay, so as I was saying, so now we still only have 2 points. What happens when you get a duplicate point? Well, that's easy. Just add another number to substitute in. I would do it again for x, because there could be a possibility that if you did 1 for y, there's times when it could both be 1, 1. So just add a new number for x. To me, the easiest next one to use is negative 1. So let's put negative 1 there, and let's come over here and substitute in negative 1 for x. 3 times negative 1 minus 2y equals 0. This becomes negative 3 minus 2y equals 0. Add 2y to both sides. We get negative 3 is equal to 2y. And now let's divide both sides by coefficient 2. The 2's cancel, and we're left with negative 3 halves is equal to y. So I'll put that in here. Negative 3 halves for y. And now let's plot that. So I'm just going to pause this to erase some work, and so I have room for the graph. So I'm going to sketch a graph, and let's plot our points. The first one is 0, 0. That's the origin. Let's just put a big dot there. Then we have 1 and 3 halves. If you want to convert it to a decimal so it's easier to think about on the tick marks of a graph, that's fine. You can do that on a calculator. So starting here, let's go over 1 unit for 1, and then we're going to go up 1, and if that's 2, a half would be 1 and a half would be right there. And then let's look at the third point. Starting at the origin, when we have negative 1, that would be here, and we're going to now go down 1 and a half units. Down 1, this would be 2, and a half would be right there. Let's analyze those points. Do they seem to fall in line? I'd say so, yeah. So let's just draw the line between through those points. All right, and before we quit this problem, let's again analyze a couple things about the graph. What's the trend of this graph? It's positive. Why? Because as you look to the right, what does the graph do? Go up or down? It goes up. Also, let's go back to the equation, 3x minus 2y equals 0. If you remember, I chose this is a standard form equation, not a slope-intercept. And I want to ask you a question. If we look at that equation, can you tell what the slope is? Not really. The answer should be no. This equation is not really that functional. We can substitute values into it and then find out what the other value would be for the other variable. You could do that with any equation. But if you look at that equation and you think that the number in front of x is the slope, it's not in this case, because this is not the slope-intercept formula. So that's mainly what I wanted to point out. The slope is not 3. All right? So let me pause this, and I'm going to put another problem on the board so we can continue with graphing linear equations. I put another equation up. Y equals negative 3/4 x plus 3. Before we go into graphing, and we're going to use a different method this time, let's again analyze the equation. Is this slope-intercept formula, or is this a different form? Is this standard form? No, it's the slope-intercept form. Okay, y equals mx plus b. And in the last two equations, I showed you how to use the 0, 0, 1 method, or the 3-point method, for making a table of 3 points to graph a linear equation. But you don't always have to do it that way. If the question tells you to do that, then you have to do that. It's good to know both methods. But once you kind of get comfortable enough with linear equations, you'll probably always want to do this method. And this method is basically using the slope-intercept formula because there's already important details encoded right into the form. So I'm just going to sketch a graph. It's not perfect. And let's start with the y-intercept. That would be 3. Okay, and remember, the 3 represents the y portion of the point of the of the y-intercept. On a test question sometimes is, if you're given that equation, what's the point of the y-intercept? You always want to do this. The y-intercept goes here for y, and this will always be 0 because it's going to always be on the x-axis, on the y-axis, which is always where x is 0. So we're going to start at the origin and go up 1, 2, 3 units. All right? And when you're sketching these on your paper, try your best to make each unit equal in size so that the graph comes out as accurate as it can be for a rough sketch. Or you could use graph paper. So we're now going to put our pencil or the marker on the y-intercept, and we're going to look at the slope, m. And we're going to do this many units vertically and this many units horizontally. Okay? I want to say, it's obvious that there's a negative in the slope here, but please remember this. Only apply the negative either to the top only or the bottom only. Don't double apply the negative, because if you do that, remember, a negative over a negative is a positive. You're going to make the graph go in the wrong direction. This is negative, so we should expect that it's going to go downward. Let's prove that. Also, let's apply the negative sign to the top only. So starting at the y-intercept, we're going to go down 3, 1, 2, 3, and then we're going to go positive to the right 4 units. 1, 2, 3, 4, and draw the point. And let's do that again. Down 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4, and draw the point. Okay, now we could draw the line, but I want to do something else just in case, because people usually do this, could do this in 2 different ways. You'll see what I mean. Let's go back to the y-intercept. And now, instead of applying the negative to the top number, let's apply the negative to the bottom number as if we're doing m is equal to 3 over negative 4. And then you'll see why I want to do this. So back to here, we're going to go up 3, 1, 2, 3, and negative 4, meaning to the left. 1, 2, 3, 4. And put the point. We have here, 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 and here. They look like they're pretty well in line, so I'm going to draw the line through them. And that's our line. Now, why did I show it with both directions? I think it's important that you start at the y-intercept and at least know how to go in both directions. Okay? Some people are more acclimated to move it down and to the right. Some people are more acclimated to go towards the left. It doesn't matter. Just be consistent, and just remember that whichever one you do is fine. Only apply the negative, if there is a negative, to either the top or the bottom, but not both at the same time. It'll make the graph go in the wrong direction. Now, let's analyze, I've been asking this, the trend of the line. What happens to the graph as you go to the right? It goes down. And down follows along with what we would expect. It's a downward trend. It's a negative trend, which is what we would expect for a negative slope when there's a negative in front of the coefficient of x. Alright? So I think I'm going to stop the video here because we got a little deeper into graphing linear equations. We looked at two methods to use for graphing. One was the 001 method, using a table of 3 points. And the other method was just using a slope-intercept form of the equation. Alright, I know I said I'm going to end this, but let's actually look at one more to tie these all together. Okay, I put one more equation on the board, which is going to tie these ideas all up nicely. Alright, this one's with a little extra challenge. What form is this equation in? X minus 6 is equal to 2y. It's not really any normal form. It's not in slope-intercept form, y equals mx plus b. It's not in standard form, ax plus by is equal to c. And it's not in point-slope formula. It's just sort of in a random form, okay? Why did I choose this? Because we can always convert into slope-intercept form. So that's what we're going to do. What we're going to do here is you don't have to do this, but let's flip sides. So we have 2y is equal to x minus 6. And now we always want y to have a coefficient of positive 1 to be slope-intercept form. So let's divide, that should be positive. Let's divide all terms by 2. This cancels out, leaving just y. And we can reduce 3 halves to 6 halves to 3. And now I think you would agree, you can see now that we have slope-intercept form. Y equals mx plus b. We have x over 2. Let's make that so it's clearer that it's the slope and x. So I'm going to make this 1/2 x. 1/2 x minus 3. Alright, and now we're just going to plot that using the slope-intercept. Start with the y-intercept, which is negative 3. Start at the origin and go down 1, 2, 3 units. Okay, that point would be 0, negative 3. And now let's start at the y-intercept, and we're going to go up 1 and to the right 2. Up 1 and to the right 2. Up 1 and to the right 2. Sorry, that's a little sloppy. Let me clean that up a little bit. Alright, and we do have 3 points. We could also go down 1, down 2, down 1, to the left 2, down 1, to the left 2. Okay, why can we do that? Well, since this is positive, in that case, if we want to go in the reverse direction, we need to make both of them negative because a negative over a negative is a positive. So, like I told you before, I like you to be able to know how to go in both directions. There's one more thing that I want to teach you before we end the video, which is, this is the y-intercept. We just found that from the equation. But what about the x-intercept? You're going to start to learn more about x-intercept. And if the y-intercept is when x is 0, the x-intercept is every point where y is 0. So what we're going to do is just substitute 0 in for y and simplify to get x. 0 is equal to 1/2 x minus 3. Okay, isolate the term with the variable, so let's add 3 to both sides to move it to the other side. 3 is equal to 1/2 x. And now let's multiply both sides by the reciprocal in front of x. That would be 2. Okay, 1/2 times 2 eliminates the coefficient 1/2, leaving x. So we get, I'll write that here, x equals 6. So to summarize that, we just found the x-intercept where x is 6 when y is 0. Okay, so we found the x-intercept. Now let's plot that and just double check that it all falls in line. Start at the origin and we're going to go to the right. 1, 2, 3, 4, 5, 6. And look at that, it falls right in line. So let's summarize what we did in this last problem. Well, we had a problem that wasn't quite in slope-intercept form. We converted it to slope-intercept form, and then we used the details, the y-intercept and the slope. We also learned how to, starting at the y-intercept, with a positive slope, go in the reverse direction to get additional points by going down 1 to the left 2. And we also learned how to find the x-intercept. The x-intercept is every point where y is 0. We plugged 0 in for y, simplified, solved for x, and that's how you find the x-intercept. Questions on a test or on homework may ask you to define the y-intercept by a point and the x-intercept by a point. So now you know how to do that. That's all for this video. I hope you found this helpful. If you did, please give it a thumbs up. Please subscribe to the channel so you can be aware of future videos that come out. Please check out my other videos on Facebook and Instagram. And remember that a lot of what we went through today is can be found on page 50 of my book, Algebra in Words, which you can find on Amazon.com. I'll see you in the next video.